If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. So here's a ASUS graphics card, and as you can see it needs a good clean. It's all inside the heatsink and everything in here, so I'm going to try pulling it apart. Now I've got no idea how to do it on this one. There are clips in here, but it looks like there's one behind here you can't actually get to. I've had a quick look at it and it looks like you can't actually get to this clip to release it. So what I'm thinking I have to do is actually remove the whole heatsink assembly. So it looks like 6 screws, and I think the whole heatsink assembly will come off with that shield in place, and I can probably get to that clip then. So let's give it a go. Little sprung screws, don't lose the springs. So I get to find out what the heatsink compound and stuff is like on it as well. It's much like CPUs, they need to be cooled properly, and then the compound can dry out and cause problems later. So we'll see how it goes. If it looks okay, I'll leave it alone. If it looks too dry, then I'll change it. Okay, and it looks like there's a warranty seal on that one. Okay, does that thing come off? It does. Excellent. Let's move this out of the way. So that's how the assembly goes on, and hopefully I can get to that clip that's down there, I think. So let's get this off. Look at this, it's oily. Oh, does that mean it's got a bad cap? And over there too. I think these electrolytic caps are gone. That's a potential problem. Okay, let's just get this thing apart and have a look. These aren't really designed to be pulled apart again, you know, they are what they are. There we go. So I had to bend them out enough to get them to stay out of the way while I could stick the screwdriver underneath it. So this is the bit I need to clean, obviously. I have to watch out for these heatsink pads, right? These thermal pads, do not lose them. Alright, so 1, 2, 3, 4, 5, 6, and one along here. Okay. Heatsink compound. That's pretty dry actually, that needs doing. Okay. So yeah, that's all dried out. That one is cleaning off. It's just, yeah, no, that's no good. But all this oily residue here, that is a sign of these electrolytic capacitors blowing. I don't know which one though. There must be through hole actually, so being through hole means I might have something I can replace them with anyway. So what we got? 3 volt. 3 volt 820. I don't have anything like that. And that's a 270 16 volt, which looks like it may be gone as well because there's some oily residue around this chip here. Or is that a MOSFET? That's a MOSFET. Something's gone. Don't know where. So we'll give it a clean up and try and get rid of this residue, because this is quite corrosive and it can actually cause all kinds of problems. I might even have to put it off something cleaner. There's another thermal pad just here too, so there's another one. So there's, what's that touching on? Over here somewhere, it must be over here. Yeah, be thermal pad there as well is what it should be. That pad stayed on that point. So 1, 2, 3, 4, 5, 6, 7, 8 thermal pads. Right. Model number of this card. GTX960. Okay, so anyone's interested. But this electrolyte, which is in the electrolytic capacitors, it is corrosive. So if you get a leak like that, it's actually quite bad. You need to get it off. I mean, I should really put it through off something cleaner. But I don't have any caps of the right value, so I might just have to maybe poke around and see if I can find out which cap it is that's actually gone. The problem with electrolytic capacitors is they don't like the heat. And yeah, it tends to make them fail. But these are non-vented. I mean, let's keep on going. Let's pull some more apart. Let's get the screwdriver actually. It's a bit bulky, that one. Let's just take off the back panel. might even have thermal pad on the back there. Wouldn't surprise me. Let's put it in a second. I think, oh no, that's okay, that bracket can stay on there. Back panel's off. So there's another thermal pad there. And all that liquid there is probably just from me giving it a clean. It's probably just IPA. Let's seep through. Maybe, not sure. So I think I'll test these caps and just try and determine if any of them have gone. If they're all in parallel, so that might give me some different options, like using a larger value. So here we go. Right. So yeah, all through hole, and I can't see if they're in parallel or not. It's all on this side. They may be in parallel, but it looks like sort of individual power supplies down here. These will be inductors. So each one of those inductors will be a different power supply rail. So these are all the same value on 820, 820, 820, 820, 820, 820. Yeah, all 820. So I probably could just test on the back of those caps there, well, there, and see what we find. Let me just get my cap tester out. Okay, I've got my cap tester out here. So I've got it set to 100 Hz ESR mode, series capacitance, and we're going to go down all these caps here. We've got those two there, and we've got one there and one there as well. So we'll check all those ones and see what we get. So I'll start the ones I'm suspicious of first. 0 ohms, 575 millifarad. Millifarad. And the same. Are these in parallel? They might be in parallel. Give them the same readings. What's that? 820, so what's that? 7 of them in parallel, something like that, is it? Could be. They could all be in. Oh, that was different. Those ones there all connected together, I think. Let me check. Let's find out. Probe on there. Yep, yep, yep. Those are all connected together like that. So is that one. It's probably ground. Okay. We'll check this one here too. Check that side. Yeah. Even though, oh, those have got resistance there, so those are a little bit different. But yeah, so those are probably interconnecting somehow, so is that one. But these ones here are all dead shorts to each other. So these are all parallel. So you can try and identify which cap is bad in that set is going to be hard. Yeah, they're all in parallel. Anyway, let's keep going. So here we have 0 ohms, 2.2 millifarad, and the same again. 292 UF, 0.1 ohms, that looks right. 783. That's a 560, so it's actually a bit high, so that cap might be bad. But which one of these is bad? That's a good question. So that's 820, 1640, 3240 for about 5,500. So yeah, 5.7 millifarad for all of them together is about right. I don't know. I mean, that oil there is usually a sign of a problem, but that one checked out fine. There was oil around here, This one's checking a bit weird, but there's nothing signed. Oh, is it all around there? No, not really. Maybe something got spilt in it. Maybe the caps are fine. I mean, that's entirely possible too. Maybe there's nothing wrong with it. But yeah, it's usually a sign of a bad cap though, so I'm just a little suspicious. So we'll just carry on. If the graphics card doesn't work, then I'll look into it in more detail. Maybe just go around, order some caps and replace them all. But I think at this point they seem alright. So we'll move on. So back to the cleaning. So this is also looks all just dry. It's not even leaving anything on my finger. Alright, that's how bad it is. Absolutely no good. That has to come off. You have to be careful with our components under here. You have to be careful. You can't just scrape away because you'll break capacitors off the circuit board here, or the resistors, whatever they are. So you have to be careful if you're doing this with a hard tool when you're trying to scrape off, because there are parts there. You have to be careful not to destroy them. So I'm just going to get the worst of it off, and I'm going to use something else. Just makes the job a bit easier and a bit less messy if you get the bulk of it off first. You'll see those parts in a second when I actually get it cleaned up enough. Okay. Now this is where it gets really messy, is getting all this stuff off. So you can just wipe off the bits I've just loosened at first. Like that. Gives you an idea. Focus. Alright, and just get it right down with this. It will gradually come out, then I'll have to probably use the brush and get between those parts. Again, you don't do it roughly, you just treat everything really carefully, alright? Now, let's get in with the brush, try and loosen off the rest of it. Sometimes having thermal compound on these components can be a problem if it's a conductive, type. Some types are conductive, and if you have a conductive paste and exposed components like they're on here, you can actually short them out. So you have to be a little bit careful about that. Right, so I think there was like an Arctic Silver, I think it's one of them. It's got conductive parts in it, so you have to be careful about not over applying it. I think it's that one. Probably some others. We actually have metallic compounds in the paste to make them work better. Right. And now you can see all the components in there, those little dots. Which is why I'm saying it's really, you have to be really careful about not scraping it or anything like that. Okay, so that's that part. Now I'm going to clean up the heatsink part as well. Now I've got to get this cover off. Actually, I'll come back to that in a second. Alright, so there's a little bit of dust in there, it's not too bad. Most of it's in the heatsink assembly, so I'm going to put this back together again. I did the testing I wanted to do on that side. There's a couple of tantalum caps here, which, although aren't assembled very well, they're on there okay, I suppose. They look alright. So I think we're good there. So let's put this assembly back together. Make sure you don't lose the thermal pad. And if there's any crap on there like this one's got, get rid of it. Get this right down. Always try and have things clean if you can. Right. Drop that back on there. Don't drag it, drop it, lift it and put it down. Alright. Long screwdriver, need the right screwdriver. When you're doing these things, get the screw in before you, well, put all the screws in before you tighten it. Otherwise what can happen is you can misalign it, then you have trouble getting the screws in, so just put them all in before you tighten them, and then go around afterwards and tighten them up. Just saves you headaches of trying to get screws in which don't line up. If you don't tighten them in the first place, you have to go around and loosen them again. So with the camera refocusing. Right, last one. Okay. Now tighten them up. This one's not feeling quite right. There's a bit of gunk in there maybe. There we go, it's going a bit better now. Okay, I think. Yep. I think it must have been a bit gunk in it. I've got tight towards the end. Right. Stuff out of the way. So I think that's basically that part done, alright. I'm going to bear in mind that these caps are suspicious. Anyway, put that to one side. Now we've got to try and do this piece. Right, so I need to get this shield off. Now I can actually get to all the clips to do it. Which is why I had to get the thing apart in the first place. So there's a clip there. Try and push it over and separate at the same time. Same here. Push it over and separate. Yep. And there's another one down there. Trying to sort of push and pull my fingers at the same time. Yep, set one, and then one here. Hopefully that'll then pop off. There you go, that's that bit. Is there something else? Is that a screw there? There's two screws in here too. Just to catch you out. Here we go. One there. And one there. There we go. Alright. Those out so I don't lose them. Best to be in control of the screws. Now this is a bit dusty in here, so I'll go away and give us a clean before I put it back together. Also got to clean this heatsink compound off here too. For the same reasons as before, it's all dry and it needs replacing. Being a flat surface, it makes it a lot easier. Alright, give it a bit of a polish up like that. Don't want any lumps on it. If you've got any lumps, it can cause problems. Alright. Again, don't lose the thermal pads. So this is the bit we need to get into. Is cleaning this crap out here. It's all inside the fan there. So I've got to figure out how to get that fan part there out. Looks like there's a screw there, there, and there. And it's also got this connector which runs through that bit there. So I should be able to lift it out. That shouldn't be a problem at all. One there. One there. And one there. There we go. Now, find the screws, first thing. You can see how bad it is inside here now. Alright, see all that build up in there? That's really going to affect the efficiency of the cooling. Big time. Alright, it's basically blocked. So that's all come out. So I'm going to go and clean that off and I'll come back. Okay, so it's cleaned up now, so let's put it back together. Should work a lot better after this. Now let's get these screws without dropping them hopefully. Again, same deal. I'll put them in to seat them and get them lined up, but don't actually tighten it yet. Same thing as before. Then tighten the last one. Here we go. Then tighten. Tighten. Done. So let's put the top bag on. Just do it this way up so I can make sure the clips are lining up. There, and one more down there. That's it. All the clips are in. Yep. Let's put those screws in. Done. Okay, so now we assemble the card. I've got to put some more thermal compound on this. Make sure it lost any pads. 1, 2, 3, 4, 5, 6, 7, 8. Correct. You did remember the number from before, didn't you? Now let's put some thermal paste on this. Now there's lots of theories about the best way of doing thermal paste, and I believe 50% of them are wrong. I mean, some will say stick a big blob in the middle and then just push it down, right? Well, yeah, that may or may not work, because what it is, it's based on squishing this blob out across the entire surface of the chip. Well, that contact area there, which is only that centre bit, the die. That's the die, right? So it's based on making sure it'll cover the area. If you don't put enough on, it won't cover the whole area, and you have overheating problems. If you put too much on, it will squish all over the place and make a huge mess like the last one was. All right, all this stuff around the outside which is unnecessary and makes a mess. So what I say is, yes, put a blob in the middle to start with, but then smooth it out. All right, get something like, I don't know, even a flat blade screwdriver will do the job just fine. Smooth this out of the way so it's not glaring the screen too much. Right, and just spread it out. Right, the important thing is that it's spread across the surface of the chip. Right, if you haven't got enough, put some more on. But it should be a thin film across the entire chip. Right, it doesn't have to be as absolutely perfect, but it's that way. If you spread it out, you know you definitely got enough on there. Right, I'm thinking right now I probably need a little bit more. Okay. Because the idea of this is to remove air gaps. Okay, if there's any air gaps, it will not cool as efficiently. All right, and that's super important. All right, so I've got some blobs there. So basically, as long as you've got some on the surface of the chip there, when you put it down, it's gonna make a better contact. Okay, so it's mostly there. Any excess you've got on your thing, just smidge it on the other side. All right. The important thing is you've got it covering the chip. Don't just do a blob and hope for the best. Actually make sure it's spread out. That is what I highly recommend you do. Right, let's put this on. Now, this needs to line up in some way or other. I'll do it this way up because I'm not going to line up the holes that way. Okay, so holes there which need to line up, which I need to try and see through. There they are. Okay. And again, this is why these have these springs on, because these are there to help hold tension on gently. So this puts gentle pressure on. So if you put a big blob on there and you don't actually squish it down enough, the blob isn't going to spread. It will just sit there, and then you have cooling issues. Right, because the larger the contact area, the better the cooling. Alright, so I'm just putting these in roughly, then I'll tighten up after. These are called shoulder screws. They actually have a stop on the bottom of them, so they don't actually go so far. That way it's only using the spring tension. Alright, the spring tension is what's holding it on, that's it. And these springs aren't that strong. Okay, they're really weak springs. Okay, there's not much to it. So there's actually not a lot of force there to actually spread that that paste across that chip. Okay, so that's it, done. Alright, cleaned up, nice. Now let's try and see if I can see down there. Give me a second. Let's have a close look at this. Well, I might be able to get you to see this on camera. If you look down in the gap here, let's get something to point with. Right, in that gap there, get over here, where it came from. In there is the gap between the GPU and the heatsink, right? So if I get the angle right, see you got some. See there's a gap there, right? Just that edge there, that is the GPU chip, the edge of the chip. Then you see there's another gap right there, right? See that small gap there? That's the gap between the step of the die and the actual body of the chip, right? So you have to make sure that if you look down there, sometimes you can see it or not. And there's the other edge. So that's the corner of the die there. And there's a corner of a die there. Alright, so you can see that it's touching. Alright, so that's the only bit that touches is that die there, not the whole chip. And not everyone understands that, but anyway, it is what it is. So that's done. That's all cleaned up and really go back in the machine. Let's check these connections out here. They look kind of okay. Actually, I need a rubber. I haven't got rubber here. A little trick, if you've got suspicious problems with your graphics, like playing up maybe, you've got the actual connector here. This can corrode a little bit, it can get a bit of oxidisation, and you look at it, oh, it looks okay, but you can get a little bit on there. Now, if you just get a standard rubber for rubbing out pencil marks, right, and you can just run along these connections with the rubber, and it will just clean off a bit of that residue. Right, I don't actually have one here right now, so I'm going to use my fiberglass brush, which is a bit harsher, so I can't do it too much, but just do that. And you may be able to see the difference in there already. You may be able to see it. I get the line it right, I don't know. But you see it's more even already, right? I can't do too much with this because it gets too harsh. But that's actually giving a bit of a clean up. Right? I can't do it too much. I'm basing on how much light I'm getting reflecting off it. And do the same for the other side. Right. These actually aren't looking too bad. I've certainly seen a lot worse than this. Looking very, very dull. But I can see connector marks on here, so I thought I'll give it a bit of a clean. If you're using rubber, it's pretty much about the same amount of work actually, but rubber, but it's much more gentle and just helps to clean off any light oxidisation. So yeah, that's done. Thanks for watching. Remember to subscribe. Oh, zoom out so you can see me. Remember to subscribe and click the bell icon and share this video with your friends if you're into computers and they need to know to clean out their fans and their GPUs or pull it apart and how to do a bit of maintenance work on them. Share it with them. They might be interested. Hope to catch you next time. Bye.